What's up, everybody? OCD Mikey, Hi-Fi Guy here. Welcome back to another episode of OCD Mikey's Hi-Fi School. And tonight I want to talk about vibration, okay, and isolation. It's been kind of a hot topic lately with those videos I did with the Live Vibe audio. By the way, Live Vibe, I don't sell it, but it is my favorite brand for isolation. It's not even isolation. I'll get into that. It's my favorite hi-fi stand brand, and my choice is Live Vibe Audio. And I'll go into the reason why. First of all, you have to think that, or understand that vibration is the enemy to audio. Okay, now, sure, you can hear fine. Your music sounds fine with no vibration control, unless you know better and you put vibration control or mechanical grounding underneath it. And then you all of a sudden release this whole stereo that you never even knew you had. You thought it was like at this level, and really it was at this level. It was higher. By removing the vibration from the component itself, you are extending your information, your recall of information. Just think of it like the vibration smears low-level detail. Okay, so it rolls off highs. They aren't as extended. It's not as airy and ambient. It doesn't have as much imaging and depth. All these things can be robbed by vibration. Okay, and so we look at the problem of the vibration. The only one to really be of concern about, and again, I'm going to tell you this in layman's terms. I'm not a physicist. I'm not a scientist. I'm not trying to be. So let's not get into whole semantics about stuff, how I say it or whatever. I'm just going to lay it on you like a brother, okay? So the bottom line is you want to get vibration out of your components. You don't want it staying inside the component. Okay? So when you're choosing to buy a component, if you buy something made with sheet metal encasement or a sheet metal around it, you have to realize that one is going to vibrate from airborne vibration that comes from the speakers. And things that are made out of solid billet, like Jeff Rowland, for instance, or machined billet plate, like Playback Designs, they're heavy as all get out. So there's not going to be any airborne vibration from the speaker that's going to be of any consequence to those pieces. They're just not going to vibrate. If you have something, and the easiest test to do, take your finger and go tap, tap, tap on the top, just like if you got your lid like that, right? Do that on top of your gear. You'll hear if it rings or not. It'll either give out a ring or it'll be dead. You want it dead, okay? So the problem is we want to get the vibration out of the unit, okay? Not only is there airborne vibration, if you have a sheet metal piece that vibrates a lot from airborne, you absolutely want to put something under it, okay? In the pieces that are made out of full solid aluminum blocks and so forth, the only vibration we really need to be concerned with from those is the power supply vibration, the 60 hertz hum that goes in there. 60 hertz is the AC wall power that you have. When you plug into the wall, that thing oscillates at 60 times per second. That is a vibration, okay? And it puts micro vibrations into the component itself. So the component will vibrate, and the circuits vibrate, and when little resistors and all this stuff, when current goes through them, and there's all sorts of different ways that vibration happens inside the unit, okay? So the thought of isolating something to isolate it from the floor or to isolate it from the shelf, that's silly, okay? That doesn't, you want to drain the vibration out of the component. You're not trying to prevent it from getting into the component because it's already in the component no matter what. It's already in the component. You need to drain it out. Just listen to me, Linda, okay? You want to get it out of there. How do you get it out of there? How do you drain it out of a component? Okay, so you've got two different ways that people do it. Some people call it isolation, and they put rubber underneath it. Let me tell you something. There is no isolation on Earth, okay? We have something here called gravity. That means everything is coupled, okay? Because something holds it all down to the center of the Earth. So that means you're just changing the speed or the velocity or the efficiency of how something moves vibration. Okay, how does it transfer vibration? How does it do that? Does it do it efficiently or not. Stiff materials do it efficiently. Things like ceramic, metal, hard metals, okay, or resonant metals. But the bottom line is you need stiff materials to move and transmit vibration, okay? So you'll see things like metal versus like the Live Vibe, for instance, it uses brass. Some people understand that brass is the best metal for vibration. It is a reason why Navy bells are made out of brass, the Liberty Bell and all that. It's always brass or bronze. It's a yellow metal, man, and it's not copper. They're not made out of copper. They're not made out of steel. They're not made out of stainless steel. So when you get feet made out of stainless steel or aluminum or any of that stuff, it's just for looks. It doesn't have nearly the function that something made out of brass will. So brass is the preferred metal. So you can go from something as simple as screwing brass cones onto the bottom of your gear and into a brass sink. When I say sink, you have to think about sink like heat sink. Heat sink is something that sinks heat. Heat goes into it. A mechanical vibration sink is something that vibration goes into, okay? So like a big block, a big circular disc of bronze or brass, in the case of Live Vibe, brass, will take on that vibration. It will absorb it, will pull it into it. You transfer into that piece. It all transfers to heat, but they just transfer to heat in a different efficiency. Rubber is much slower. Delrin is a little better. That's in between rubber and metal. It's Delrin. It's a harder plastic. That does it better, but it's still slow compared to metal. So your sounds will be different when you use a rubber isolation device or with a spring or whatever versus a rigid coupling, which transfers very efficiently and very quick. It's very quick. That's why you hear those little fine details and you get quick transient response, and dynamic bass and punch comes from that rigid coupling. The best possible way we could rigidly couple would be to sit on a concrete surface like I am right now, concrete slab. We drill through the slab 8 feet down into the earth. We pour concrete and we sink in rods that are brass rods that go all the way down into the earth 8 feet, pop up through the ground here through the slab, and then we make a rack right on those 3 rods that come up. We put our gear on top of that. That directly, truly grounds it to the earth. Now we are fully mechanically grounded. Everything else less than that is a half measure, or a half measure, I should say. Maybe not half, an incremental less measure of the actual bomb proper way to do it, which would be go into the earth, okay, with brass rods. Some people do that, okay? I don't. I use the Live Vibe stands, which to me has the greatest bang for the buck, not as much trouble. And I'm going to go into the different devices and show you some examples right now so you can see what I'm talking about. Okay, so hold on.